we will move to our next segment, which is on our winterization program. We have two speakers today. We have John Wolf, who is in the generation department with PJM. We worked very closely with PJM last year to visit the entities that were in the PJM footprint. John has over 38 years in the generation and electric utility industry. He started out in the 1980s in field service with coal, oil, and gas, most of it steam generation. He is currently a senior lead engineer with PJM. It was my pleasure to join John on a couple of site visits this year for our winterization site visit, and we're very happy to have him join us today on this particular topic. I'll go ahead and also introduce Brian Zegman before we get started, who is the general manager at Hamilton Liberty plant that is owned and operated by Cogentrix. And so Brian, before getting into the power plant end of the business, spent 30 years with DuPont. And then he started out at the Hamilton Liberty plant in when it was first being started up. It went commercial in 2016. He spent a couple of years in the I&C, the Instrumentation and Control department, before moving into the engineer role for a couple of years, and then as the maintenance manager for a couple of years before he went into his current role as a general manager, where he has served for approximately 4 years. So he has seen this plant from the time that it was constructed all the way through these different departments. So he has definitely a great amount of depth. He will have with him today one of his staff members, Sean. So with this, let me turn it over to let me first tell you a little bit about the history of our program. So we started this program back in 2014 after the polar vortex. And so with that, RF was started up the program. It was kind of small in its inception years, but it's grown over the years. It is a voluntary program. You can request a site visit through our Assist Visit program. This is totally outside of compliance. It's focused on sharing best practices. So the slides that you'll see today, the information that we go through, this is what we focus on. We're more than happy to look at your procedures, but we're not looking at it in the context of compliance. We're looking at it in the context of best practices. We completed approximately 20 of these last year, or at least in the last winter season. We do start with a survey once we make contact with the plant. We have a few example questions over here on the right-hand side, just general information, trying to get a sense of the lay of the land. And we would love to continue this program this year. And with that, we will move into John Wolf's portion here. John, take it away.
Thank you, Mike. And just a little added insight on my previous life in the power plants. I was actually the recipient of one of the first visits conducted by RF for these back in the 2014-2015 timeframe. So I've now had the ability to see this from both sides of the fence, if you will. PJM first began collaborating with RF during the 2023-2024 season for the winter readiness site visits. And the main goal of these visits are to help generators improve their performance during cold weather and winter events. So during the first season, we were only able to assist with a few of the site visits. This past winter, the 2024-2025 winter season, we were able to support 14 of the 20 different site visits that ReliabilityFirst lined up. And to be able to staff enough to collaborate with all of these visits, we use PJM personnel from multiple groups within our organization, in addition to the generation department, with some members from the executive team, our performance compliance group, state and member training, and dispatch all get involved in these, which gave us a nice cross-sectional view of people to get involved and get different perspectives and things to look at. So basically, each site visit's opened up with an introduction, and then RF kind of gives a review of the purpose and scope of the visits. Once that's completed, we'll go ahead and go over an operational basics PowerPoint presentation, provide a high-level overview of how PJM functions and the roles that generator owners and generator operators in the overall grid or bulk power system work together. And we found this presentation to be very beneficial to bridge the gap between GOPs and PJM, as many of the power plants now have third-party marketing companies that interface directly with PJM, whereas in previous days, plants had that direct relationship. We find that's not as available much more with the third-party marketers. So kind of gives us in front of the generator owners, operators, and gives them a better feel for what we do and why we do it. The site visits include coal-fired power plants, simple and combined cycle combustion turbines, and renewables, including wind and solar. Next slide, please, Mike. So the highlight of PJM's operational basics presentation. First off, it's basically an overview of how PJM works, pointing out our main focus, which is keeping the lights on for 65 million people, and some other key statistics. Basically, who we are, what we do, why we do it, and how our performance is measured. An overview of the grid and the interaction between PJM and our members. Our generation dispatch operations and scheduling. So why do power plants get selected in day-ahead markets or real-time markets, and how all of that works? How transmission system operations can actually affect how plants are dispatched to control for actions and contingencies. And what we found overall, the presentations generated good discussion, and in some cases even spurred follow-up training sessions as requested by plant owners and operators, where our state member training will actually go out and go in more detail. Some key findings or best practices that we have found is, one of them being shown here, is measuring heat trace loading. So a lot of times there's just indicator lights, either indicating a fault or power to a heat trace circuit. Some entities have upgraded and actually installed ammeters to where they can measure the current drawn individual heat trace circuits. And in conjunction with that, they typically display an expected values chart, which can kind of be seen in the left photo in the left-hand door there. That's actually a chart showing what the expected amp draw is when those heat trace circuits are in service. Now, this is good for many heat trace circuits, but self-regulating heat trace, this will not work for, because that amps vary much more drastically on that. Next slide, Mike. And another key finding that has been implemented at a lot of power plants are temporary windbreaks or enclosures. These are erected in known areas where wind or heat loss typically results in cold weather-related issues. Temporary windbreaks help to retain any heat that's generated from the processes and prevent the wind from dissipating that heat. And in some cases, temporary heaters are also installed in these enclosures to provide heat when the plant may be shut down, just so systems don't freeze or become unavailable while the plant is not in operation. And typically, they remain a temporary situation, because in the summertime or warmer weather, if these were let in place, they would retain too much heat and provide operational issues of overheating instrumentation or other adverse effects in the summertime. So that's why in some cases permanent structures are not built and left there altogether. So with that, I'll turn the presentation back over to you, and we can move on to Brian.
All right, thanks, John. Appreciate that. So these are a couple examples of best practices, and as we move into these next slides, we're going to shift over to Hamilton Liberty to hear about their program. And Brian, feel free to introduce any of your staff that you have with you today.
I will. I invited two people. Shane, as you mentioned, Shane is an INC tech. I'm going to let him talk about the heat trace checks that we do through the summer. And I have Brad, our maintenance manager, who created our cross-reference spreadsheet that is a huge help. We'll talk about those later.
Okay, thanks.
Yep. So Hamilton Liberty, we are a combined cycle natural gas fired plant, 800 megawatts nominal power rating. We went commercial in 2016. We're located in Towanda, Pennsylvania, and we're owned and operated by Cogentrix. Next slide. Air inlet heating. So the air inlet heating reduces the chances of snow blocking the intake filters during a winter storm. And so far, while we have an air filter puffing system, it's proven unnecessary thus far in our operation. Now, I would say that's thanks to the air inlet heating. Next slide. So you saw some temporary enclosures earlier. We installed permanent enclosures with supplemental heating where temporary enclosures historically were needed. This is a shot of our condensate pumps. We installed electrical supplemental heating in some of these buildings, and in others, we rely on supplemental propane heating. Winter supply cabinet. So cold weather response supplies are kept in a common location. This reduces lost time when responding to a cold weather emergency. And some of the things we keep in there, we have tarps, spare propane heaters. We had some battery powered auxiliary equipment, PPE, and so forth. Just everything in one spot. So when you need it, you don't waste precious minutes looking for it. Next slide. Local visual indication. So what you're looking at here, this is an instrument enclosure. An O'Brien box is the term we use for these. During extreme cold weather, knowing you have no tripped heat trace circuits isn't good enough. These O'Brien boxes protect wet instrument impulse lines and transmitters. And each box has a thermostatically controlled heater inside to condition the temperature of the box. These local thermometers provide instant feedback to the APOs when they're doing rounds that, yep, I don't have any trip breakers, and hey, my heaters are working. In some cases, in critical panels, we put iMonitor sensors in these boxes, and we'll talk a little more about that later. Next slide. So here's an example of our heat trace panels. We don't have ammeters, we have a bunch of indicator lights. The panel operation must periodically be verified. Recently, we added additional status monitoring and feedback to our distributed control system. And what that does is that enables immediate action when a problem arises. So these panels, you see there's a bunch of indicator lights. Each one of those represents a circuit in that panel. And that light illuminating represents the breaker on that circuit being tripped. Operators have to periodically do a lamp test to make sure all the lamps are working. And then they rely on those indicators to tell them no breakers are tripped. And there was a fault relay, but it wasn't tied in any systems. So what we did is we added more logic, relay logic in the panel, more dry contacts, and we interfaced those dry contacts to our DCS system. And among those dry contacts is any breakers tripped, the heaters are energized. And what this does is we get an immediate indication now in the DCS. you can imagine when it's dependent on operator rounds, if a breaker trips 1 minute after that panel was visited, you don't know it until the next visit. Now we get an immediate indication on the DCS. And lastly, we did add the capability to energize these panels from the DCS. And we've been exploring ideas to actually start and stop the panels from one central thermostat rather than a local thermostat in the panel. Next slide. Here's another good indication that all is well. And these are end of run lights on, in most cases, these would only be on self-regulating heat trace. But it's telling you that you have power to the end of the run of that self-regulating heat trace. Therefore, the run should be functioning completely. Next slide. All right. So this is something that we created years ago when I was in the INC shop. We started out doing heat trace panel checks, and we built a spreadsheet where we calculated the expected current for each circuit. And then we go out and we actually measure the current, and we look for leakage current to ground. So the condition of all heat trace circuits has to be understood so that maintenance resources can be correctly utilized. We do an annual in-house check, and we rank the condition of each heat trace panel circuit. And then we use the results of that ranking to develop a maintenance plan and to, proportion our budget to where it's most needed. I mentioned that this check is performed in-house by our INC shop. It's typically done early in the year, and it's complete by about the June timeframe. I'm going to turn it over to Shane. He's our INC gentleman who does these checks for us. Go ahead, Shane.
How's it going, guys? So just kind of explain what's on the sheet in front of you. So the first checks that we do is just start whatever the actual current is when the circuit is first energized. So it's like a cold current check. And what we do is we just compare that check with what we expect the current to be and based off of like historical data. So we can tell over time if the circuit is actually degrading or not. The next check is a mega check, and that one is where we check the resistance between the circuit and to ground, which the lower the mega reading just indicates the potential for a ground fault or future issues that could possibly come up, right? And it's also compared with historical data. Mainly, so we can see if the resistance to ground is actually degrading over time. And then lastly, we do a leakage current check. So what we do is we actually compare the current between the line voltage and the neutral. And the reason why we do that is one, it kind of just confirms our mega readings, and two, it can also give us more of a resolution of any type of leakage current that could possibly be going through it. And like Brian mentioned, so usually we try to start these checks and like starting in May, try to have all the checks done by June. So therefore, we have July to kind of really investigate any issues that might come up. And we usually try to have work plans or the problems resolved by the end of July, so we can start, if we need contractors to come in and replace sections of heat trace that we couldn't really do on our own, like it gives us that ability to plan and budget for it. Yeah, that's pretty much it for the checks, I would say.
Right.
I mean, the big one is that a lot of our problems that we've been finding have been leakage to ground. Our breakers are GFCI breakers, and they only allow up to about 30 milliamps of leakage. So any leakage to ground is really what the main faults are, and it's usually within the terminations of the heat trace.
Yeah, I just wanted to point out self-regulating heat trace was mentioned when John showed us the current meters, and he's spot on. With self-regulating heat trace, it's really tricky to take a current check because as that heat trace warms up the circuit, it naturally increases its resistance and drops its current draw. So we've learned, Shane mentioned a cold current check. So when we check a circuit that has self-regulating heat trace, we have an ammeter, a clamp-on ammeter ready to go. And when we first energize that circuit, we take a current reading, and that gives us some consistency in those self-regulating circuits. Shane also pointed out we have GFCI breakers, and what we find is most of our issues, it isn't heat trace shorted to ground and tripping a breaker because of excess current draw, and it's not heat trace burning open in a lot of cases. It's leakage to ground causes that breaker to trip for ground fault protection. That's what most of our issues are. So we've adopted a ranking system, and you can see that on this spreadsheet in the column with a lot of green and one yellow cell and a red cell. Most of those numbers are 550, so we had 550 mega ohms to ground. There's one that is 6.4. That's 6.4 mega ohms to ground. That circuit is serviceable, but we're watching it. That's not normal. It's leaking to ground. There's a circuit that's in red is 0.7 mega ohms to ground. That makes it on our on a special list where we take all the circuits that have a lot of leakage like that one, and we look at criticality of what's on that circuit, and then we start to boil and cook down a repair scope for the year. And anything less than 1 mega ohm, definitely, if it's on a critical circuit, gets repaired. So that's what we're doing with that heat trace panel check every year. Next slide. You heard me mention iMonit. So iMonit is a wireless system that can transmit sensor data wirelessly. And we don't transmit it to our distributed control system. We transmit it to a standalone computer. And if we go to the next slide, you can see that the system is based on a wireless gateway. And here's a picture of the gateway. Next slide. And in the field, you install wireless transmitters. That's the device with the antenna. And then various sensors. You could do RTDs, thermocouples, pressure sensors. You can get different sorts of sensors. We use a lot of thermocouples, obviously, and this is an example of a thermocouple. Next slide. So here's an example of a thermocouple applied in the field. This is a location that our operations group has learned is a concern. We maybe had some freezing in the past that we had to deal with. So we embedded one of these iMonit wireless thermocouples under the insulation here. Now we have continuous monitoring of that location. Next slide. Here's an example of a root valve in the field. We had issues where we transfer from a hard piped impulse line to a heat traced bundle, and there's usually isolation valves where that transition occurs. Those isolation valves are a real repeat offender on freezing. So in this case, we installed an iMonit right on those valves, and we're continuously monitoring. Next slide. Now here's a screenshot of the standalone computer we have. It's actually a web-based system, and it shows many iMonit points. Each point gives you a description of the sensor, the last value that was reported, how many minutes ago the report came in, the signal strength, the battery strength, and there's a go, no-go indicator. This system can be set up to send emails and texts when a problem occurs. Next slide. Now, to help operators respond, let's say we get an alarm on that previous screen. This is a map of our plant, and we show where we have iMonitor sensors located, those little green boxes. That helps drastically when an APO gets an alarm and has to spring into action. He doesn't have to think quite as hard about where it is he's going on the plant. And the next slide is another picture. And here's an example in the lower right-hand corner. If you hover over one of these sensor indications, you'll get the description and the last reported value. So it's very helpful for the operators. Okay, next slide. And I'm going to move aside. I'm going to let Brad describe this, because this spreadsheet was Brad's brainchild many years ago when he was in the INC shop.
Yeah, the main reason we built this is we identified the very first year of operation that if we had a, let's say, breaker 8 in unit 10 BJCO2 cabinet trip, we had no idea, no quick way of figuring out what equipment was put at risk because of that trip breaker. So we went through every isometric drawing and cross-referenced it to a P&ID, a plant P&ID, and also listed for every heat trace number where on the pipe it starts, where on the pipe it ends, with all of the associated piping and instruments that it's protecting. So now if one breaker trips, we can go to the spreadsheet, filter it for that heat trace panel and that breaker, and see everything that's protected by that breaker. It's really quick. It works very well. And the other thing that helps us, we learned afterwards, is when we get to an outage, and if we have a certain section of pipe that we know we need to take heat trace and insulation off of, it can very quickly help us build the lotto because it works in the reverse. We can identify a panel and a breaker that needs lotto based on the equipment we need to work on.
Yeah, and I should add, so my little introduction for this slide was when a heat trace issue is experienced during severe weather, quick response is imperative. And you heard Brad say we were losing precious minutes. We knew we had a breaker trip. We knew what breaker it was. We didn't know what equipment was impacted. And it took a lot of time to go grab P&Is and isometrics and heat trace drawings and figure it out. This spreadsheet takes a 40-minute job and turns it into a 4-minute job. And that can be the difference in saving your plant. All right, next slide. So here's a shot of our compressed air dryers, probably pretty standard stuff for a power plant. Dry instrument air is essential for reliable winter operation. We have dew point meters right at each dryer, and readings are taken each shift on those meters. We also installed end of run sample points on each turbine unit. And quarterly, we do air quality verifications at the end of the run, just as a peace of mind and confirmation that we didn't get moisture out into our piping. And you know, that's important through the summer because we could put moisture in that piping through the summer and not know it till we get into winter, and then have that moisture start to freeze in all of our instruments. So that's an important aspect. I believe that's the last slide for Liberty. So back to you.
All right. Well, I appreciate that. That was really great. We had a couple questions that came in. One was, could you go through a couple of examples of how you use this information that comes into the screen on the iMonitor?
Well,
You want me to answer that?
yeah, go ahead, Brad.
So when we have cold weather, the operators keep this display open all the time in the control room. And we set rules where if any one of these devices sees a temperature under the insulation colder than 38 degrees, it will send an email to selected people and a text message to selected people to notify them, as well as a text message to the control room that is kept in the cell phone that's kept in the control room.
So, if that one picture of an I-monitor on the root valves, we had a perfectly functioning heat trace circuit, but that insulation wrap was just slightly compromised, or maybe not even compromised, not as adequate as it could have been. And those root valves were freezing. So it's a peace of mind that, a heat trace circuit insulation is probably 80% of the equation. So your heat trace appears to be working normally, but if that insulation's not doing its job, you're going to have a problem. These I-monits are the feedback that the whole system is working.
All right, thank you. The next question that we have, I'm looking over here to read them, but was related to return on investment regarding the wireless sensors. The question would be, do you have an estimate or an idea of what the return on investment would be for someone who's just getting started? I realize that would be site specific, but the question was, do you have kind of a guesstimate of what your return would be?
Brad, you're familiar with the cost of the system.
Each sensor is around $240, I believe. The gateway, I think, was around $200. And then we have an annual fee based on the number of subscriptions. We have 50 sensors. I think we pay, it's like $150 a year. So it's very affordable.
Yeah, it's crazy affordable. And also, their question may be coming, well, gee, how long do those batteries really last? Well, it's crazy. These wireless transmitters are super smart. They go into a low power mode and they watch the temperature they're monitoring, and only when they see the temperature change by a certain percentage do they power up and transmit a new value. So I think we have batteries that are like 2 years old, right?
I believe we have some that are still the original battery. They're probably pushing 4 or 5 years.
So yeah,
they do get good battery life because they only power themselves up to transmit every 2 hours, as long as they don't recognize the pipe is cold.
Right.
If they see the pipe is cold, then they transmit every 4 minutes, I think it is. It goes into an aware state.
So the return on investment, honestly, if you save yourself, you don't even have to save a trip to return your investment. Even a D rate.
And we took the cheaper route because I honestly didn't think it was going to work. That's why I got the gateway and the cloud-based server. Our sister site actually bought a hardware standalone server, which is a more expensive route, but it does buy you more options also. But honestly, the cloud-based is working really well for us.
All right. The next question that we have that came in was, can you explain at a high level how you train personnel on cold weather preparedness, and do you change staffing levels as you're approaching cold weather?
So yeah, we do. So we do quarterly training on cold weather. We have a winter preparedness team within operations, and they are doing, like for instance, in April, they'll look at all the issues that we had through the past winter run, and they'll make sure that we have some kind of plan to address those. When it comes to cold weather, when we get below 32 degrees, we have a critical component checklist that we start checking. And when we get below, and I don't remember, is it 20 degrees? We increase the frequency that we do those checks. And when we get into that kind of weather down there, 10 degrees and below, yeah, a lot of times we will bring additional people in because we have additional rounds to make. And, we quite often in negative degree weather, you're reacting to some of these iMonitor probes telling you there's something going on. So you're going out and you're investigating, maybe bolstering insulation and so forth. So yeah, it definitely takes additional resources when you get into extreme cold weather.
All right, the next two, thank you, Brian. The next two questions actually are for the RF staff about the program as a whole. So one is, how can they sign up for a winterization site visit? And so this is pretty easy. You can just email me or reach us through our Assist Visit contact on our website, but just reach out to us. We would be happy to visit with you about your needs and discuss timing. The second one, I think, was a related question. What if I have a fleet in multiple regions? How would I get started? That kind of depends on whether you're in the multi-region registered entity program. If your company is part of the MRRE, where you have a lead region, you typically start with that lead region. We can facilitate that if you're not sure if they have a winterization site visit program. RF would be happy to basically collaborate with that region to answer your question. But once again, start with the regions where you are registered. And if you're not sure about that, you certainly are welcome to reach out to us. We have the contacts with those regions and we can reach out to them. Brian, I appreciate your time today. Thank you for your staff. And John, thank you for joining us as well. And for today, that will wrap up our Tech Talk.